Next up that we're going to talk about is torque. Torque now is something that you've heard of before and is used somewhat in our everyday language, but isn't often used correctly, although we have a generalized idea. Torque is the measurement of a turning force. If we were going to simplify it down, a turning force causes an object to rotate. Now, technically, it's the cross product between radius and force. Now, that's a complicated mathematical term we're not going to worry about, and that could simplify down to the distance times the force times sine theta. And we're not going to use that either. The equation you need to focus on right now is this. Torque is just force times distance. The units are newtons times meters. Now let's talk a little bit about this equation here. If we're not at an angle like this, where the force isn't hitting perfectly perpendicular, instead if we're at a position something like this, where we have a pivot spot, pivot point, which an object rotates around, and a force being applied perfectly perpendicular to it, we don't have to worry about this sine theta, and so all the problems we do will be where everything's nice and perpendicular, so you don't have to use the sine theta. Torque is F times D, where your force is the amount of force that's being applied, and D is the distance from the pivot point to where the force is being applied. Now that gives a few logical things. The further out you place your force, the more torque you're going to end up having, right? Because the larger the D, F times D. So if I move this force in a little bit more, you're not going to get as much torque at that point, which is something you probably felt before. That's why wrenches tend to be a lot longer, right? The more length you have with your wrench, the more torque you have, the easier it is to turn whatever the bolt is or anything else. Torque can also be applied to circles, where you have the radius of the circle would be the distance there, so that'd be your distance, radius of the circle, assuming that the circle is perfectly symmetrical, that we don't have anything wacky going on, like more mass over here and then less mass on the other side. But perfectly symmetrical, there's the radius of the circle, and then the force being applied to the outside. In our problems, notice there will be a right angle between that. And this kind of says centripetal motion to you, although that would be a tie-in we would do much later. So to boil torque down, here's your equation, force times distance. The force and the distance must be perfectly perpendicular. If they weren't, we'd have to use this sine theta where the angle was between the arm and where the force is, but we don't have to deal with that right now, just force times distance. Units, newtons times meters. Now these torque problems are actually very straightforward, so here's an example. I have a bolt here. It looks like it's on some type of engine, and it requires at least 350 newton meters of torque to actually turn. As long as you're over that, you'll cause it to rotate. And obviously any extra you apply, you'll actually you'll accelerate it rotating around. But that's what's required to actually make it turn. How long of a wrench do we need? So if we use too short of a wrench, it would be impossibly hard to turn. Maximum force the person is going to be able to exert is 320 newtons. So if you use too short of a wrench, then 320 newtons isn't going to be enough. And the longer wrench you have, the easier it will be to turn. So we rewrote our equation. I should point this out. I didn't in the last slide. This is Greek letter tau. It kind of looks like maybe a J with a squiggly top, or you could think of it as a T with a hook and a squiggly top for Greek letter tau. But torque equals force times distance. Now I have my force, right, that I'm going to exert, and I have how much torque I need, allowing me to solve for distance. Divide now both sides by 320 to get it over. And I end up with a wrench that the wrench has to be at least 1.1 meters long. Now that's a very long wrench, much longer than you would use like something small here on this little bolt. This would be a wrench a meter long. It would be incredibly heavy, but you use these kind of wrenches on large machinery where you have insanely large bolts that require a ton of torque to try to turn. So the longer the wrench, the easier it is to turn. So a 1.1 meter long bolt, 1.1 meter long wrench, you're going to end up needing that to turn a very, very large bolt, which is the beauty of torque. If you have something that is really hard to turn, it's not that you need to push harder, it's that you need a longer wrench or a longer torque arm, something to turn it with. The more distance you have, the more torque you have, while still being able to apply the exact same force. And it's a lot easier to go out and find some longer object to attach and turn than it is to somehow or another muster up more strength than you actually have. All right, that's the basics of torque. The only thing really to be careful of is making sure that you pick out what's what for the equation. Maybe you need to do a variable bank. That would be a wise thing to do. Torque equals 350, and then force equals 320, and D equals question mark, how long must it be? D equals question mark, substitute into the equation, rewrite equation, substitute in, and then solve.